In this video, we're going to look at a fundamental theorem of calculus, part 1 and part 2, and some examples. Assume f of t is continuous on the closed interval ab. Part 1 of the theorem states if the function g of x is defined by capital G of x is equal to integral a to x f of t dt for all x in a closed interval ab, then g of x is continuous on the closed interval ab and differentiable on the open interval ab. G prime of x is equal to d dx of the integral a to x f of t dt, and that's equal to f of x. Now, the key point here is that the derivative cancels the integral, and this x, this upper limit, goes inside for t, and you just get f of x. So derivative cancels the integral, and you put the upper limit inside for your variable t. So we have a drawing here. Let's notice some things. So what we have is, let's assume that the function f of t is larger than 0. G of x is equal to integral a to x f of t dt. This is just going to be the area under the curve. So that's just area. G of a is the integral from a to a f of t dt. And we know this area will just be 0 because it's just a line, it's just a vertical line and has no area or area of 0. If you change the upper limit x to b, we get g of b is equal to integral from a to b f of t dt. This would be the area under the curve from a to b, area under the graph of f of t from a to b. All right, so here we have an example. We have the capital G of x is equal to integral from 2 to x t e to the minus t dt. The question here asks to find a derivative g prime of x. So let's apply the theorem. G prime of x, that's equal to d dx integral from 2 to x t e to the minus t dt. So now we know from the previous theorem that the upper limit x gets substituted in for t, and the derivative cancels the integral. So we're going to get x e to the minus x. That is the answer. All right, so now let's look at part 2 of the fundamental theorem of calculus. So what we have here is if f of x is continuous on the closed interval ab, and capital F of x is any antiderivative of f of x, then the integral a to b f of x dx is equal to capital F of x. Capital F of x is the antiderivative of small f of x, and that's equal to f of b minus f of a. Notice that this f of x here is the integrand. That's f of x. This capital F of x is the antiderivative of small f of x. And this line here means evaluated at, so we get antiderivative f evaluated at b minus antiderivative f evaluated at a. Let's look at an example. So here we have integral from 0 to 1 ax squared plus bx plus c dx. You will notice that the function ax squared plus bx plus c is actually a polynomial function, and polynomial functions are continuous everywhere. So it's continuous on the entire real number and entire real numbers from minus infinity to infinity, and definitely it will be continuous on the closed interval 0 to 1. All right, let's evaluate this by applying the fundamental theorem of calculus. So integral from 0 to 1 ax squared plus bx plus c integrated with respect to x, that's equal to ax cubed over 3. So we reverse the power rule. Integral of x squared is x cubed over 3 plus integral of bx, that's going to be bx squared over 2. Reversing the power rule, antiderivative of x is x squared over 2 plus integral of c is going to be cx. Evaluated at from 0 to 1. Let's plug in 1. We get a over 3 times 1 cubed plus b over 2 times 1 squared plus c times 1 minus, now plug in 0, that's a over 3 times 0 cubed plus b over 2 times 0 squared plus c times 0. If we simplify this, we simply get a over 3 plus b over 2 plus c. All right, let's illustrate this with a diagram. So we know that what we have is a quadratic polynomial. Y is equal to ax squared plus bx plus c. This is a quadratic polynomial, and let's assume that is above the x-axis for x between 0 to 1. So the area that we have found is a over 3 plus b over 2 plus c. What does this area represent? It is actually the value of the definite integral 0 to 1 ax squared plus bx plus c. This is equal to a over 3 plus b over 2 plus c. All right, thanks. I need to make a correction here. The integral is with respect to x. So let's fix that. The definite integral is integral from 0 to 1 ax squared plus bx plus c, and the integration is with respect to x, dx. All right, thanks.